Hello, my name is Lawrence of LearningWhilePracticing. For this section, we will discuss the concepts of classes and objects, and how do we create objects from classes. And then, as we go on, we will also discuss the concept of constructors, instance variables, and instance methods. And then, we will discuss the concepts of a test class. What's the purpose of a test class? All right. In this example, we have created what we call a person class. So public class person, and then I have a bunch of some codes inside this. Now, the first two lines are what we call instance variables. So I have two instance variables called name and age. Now, just like any other person, our names are usually of string type. Let's say your name and my name. My name is Lawrence, so the value that I can give to this variable is Lawrence, and Lawrence is actually a string data type. And then I can talk about my age, which is a whole number value, which is of type int, or an integer. Oh, by the way, anything that starts with a double slash in your code can be considered as a comment. Comments are parts of the codes where you can put notes, that you can put some description about your code, so that in the eyes of a casual reader, they would probably understand what the code is all about without learning Java. So I've placed some comments here. This talks about these lines of codes right here. And this part right here is a method, which is called say hi. Now, this is also what we call an instance method. Later on, I'll be discussing in a more detailed manner what instance variables are and what instance methods are. But for now, we have a class, we have two instance variables, and then we have a method called sayHi. Now, if I save this, we know based from the previous section that when we compile this code, we won't be able to run it. Can you guess why? If you say that the PSVM is not there, then you are right. Remember, in the previous section, we've talked about the public static void main string args. And so far, we haven't had that in this sample code. So, where do we write the PSVM method or the main method? We can create what we call a test class. So this is your class, public class person, and the test class will be probably named something closer to that. So we create our test class here, which is also which can also start with the words public and class. Now, the reason why it's called a test class because it tests a specific class. The class we're trying to test is called person. So it's just fitting that we name our test class as test person. And then we can put our PSVM method here. So can you still remember how the PSVM goes? If you say public, static, void, main, string, args, then you are correct. Okay, so this is our test class that contains the PSVM inside. So, what do you think is the purpose of our test class? Our test class is used to test objects that we can create from our class. Since this is our class, by definition, class is actually a blueprint of an object. When you say blueprint, it is like a blueprint of a house. Whatever structures that you've placed, that you've drawn in your house, every time you create a house, every time you build a house, or every time you instantiate a house, everything that is found in the blueprint can also be seen in the actual house. So in our blueprint, so far, we have indicated two variables and one method. It simply means that when we instantiate an object from this blueprint or from this class, we will see these two variables and this method inside those objects. All right? So, where do we put or where do we create those objects? We create them inside our test class. Let's try to create two objects. First, let's call person, the name of the class, and then the name of the object. I'll call this P1, new person. Okay. Now, there are two ways on how to create the object. You can create an object using a single line, like person P1 is equals to new person, or we can actually split this single line into two separate lines. We can say person P2 is equals to new person, and then we can, oops, this is the same, right? So let me just remove this one. Okay, so this is how you declare a variable, and then followed by the instantiation of the instantiation process. We can say P2 is equals new person. So this single line is used to declare and instantiate an object, while this one is used to declare an object. Now the object will be referenced by the variable name P2, the data type is person, and the next line is used to instantiate the object. Now, instantiating an object, meaning to create. You are now creating an object. So let me go back to my analogy of the house and the blueprint. So if you draw a house, that's what you call a blueprint. This is actually the blueprint of an object, your class. And then when you start building the house, you should have a guide. That guide is your blueprint. And this is how we create or we build our object. Now, building or creating an object requires you to call a constructor. What is a constructor? In the next video, we will discuss what constructors are. For now, we have created these two objects, P1 and P2. Hello again. This is Lawrence of Learning While Practicing. Let's continue our lesson. So we have our class person that contains two instance variables and a method called sayHi. And we have instantiated two objects. Now, instantiating an object will require you to undergo two processes. We need to declare a variable, and then to instantiate it, we need to call a constructor. Now, we have P1 and P2. We have created two objects in two different ways. Now, what does it mean when we have created an object? It simply means that a copy of all of these instance variables and instance method are given to each object that you have created. In this case, P1 and P2. So P1 has its own set of copies of these variables and methods, as well as P2. So let's try to put the identities of both P1 and P2. Let's assign values to them. So since P1 has its own name and age, we can now assign the value, assign the identity of P1. Let's do that. We can say P1. Now, to call the instance variable, we have the operator dot. So we say P1 dot name, and then we can assign a name to that. Let's say Lawrence. And then we can also assign the age of Lawrence. Let's say P1 dot age. Let's say my age is 25. All right. Now, we can also assign the age of the second person, which is P2. Let's assign the identity of P2. We can do that by calling the object's name P2 and then call the variable dot name. All right, let's give it a name. Let's say Joe. And then we assign the age of Joe. Let's say P2 dot age, and then let's say Joe is 10 years old. All right, so this is how we call the variables of each object. Now you might say, how come there are two versions of a name and two versions of an age? It's simply because P1 has its own set of copies of the variables that you have declared in your class person. That's why we were able to call the name and age of P1 and then the name and age of P2. Now, let's call their method say hi. So if the first object, say P1, will say hi, we say P1 dot say hi. And then we also say P2 dot say hi. P1 and P2 have their own copies of the method say hi. Now let's try to dissect what does say hi do. So say hi is a method. It doesn't accept any value. That's why you have empty parentheses here. And then the return type is void. Return types are basically a value that you can get from a method. In this example, you're not getting anything from the method. What the method does is it prints a bunch of values like, hi, my name is, and then the value of name. I am, and then the value of age, and then years old. Let's try this out. So we have this code right here. Now, we have saved this previously. Okay, so just to double check, you have test person, you also have person. We have two Java source codes that needs to be compiled. Which one do you think should we compile? Should we compile test person or person? Now, if you will look inside the code, there's what we call code dependencies. Code dependency is when a Java source code calls another source code. So inside my test person.java, it actually calls the person class. And person class can be found under person.java. So all we need to do is to compile this source code so that the compiler will automatically compile the other code right here. Let's test that. So we have two Java source codes. Now, when we compile in the previous section, we said that we typed javac, meaning Java compile, and then the name of our Java source code. We say test person. Now, when we press enter, oops, I have a bunch of errors. Unclosed string literal. So it can be found under person.java, line 12, and then this is where my enclosed literal happened. Let's go visit that source code. Java, line 12, here we go. So we have a begin end double quote. We have this, and then we have a begin end double quote. Now, remember what classes are? They are used to concatenate values. And then the value of age will be concatenated. And then we have a begin. And then there we go. We're missing a closing double quote. So we need to put an ending closing quote here. So after we've done editing our code, we save it. And then we recompile it again. And then there you go. We have a successful compilation. Now let's check what happened. We compiled the code test person. So we compiled this. But notice that the test person.java produced a test person.class as well as that person.class. Simply because when we compiled our first code, test person.java, it calls this class here, calls this class, person, which in turn will compile this class right here. That's why the first Java source code that actually compiled is person.java. It produced person.class, and then it will continue the compilation of test person, therefore producing test person.class. All right? Okay, so after a successful compilation, we test it, we run it by typing Java test person. There you go. Hi, my name is Lawrence. I am 25 years old. Hi, my name is Joe. I am 10 years old. So there you go. We were able to call that say hi methods, the instance methods of from both P1 and P2. In the next video, we'll talk about constructors. Hello everyone, this is Lawrence De Camora of Learning While Practicing. For this specific video, we will talk about constructors. Constructors are method-like constructs that has the same name as the class name. Let's revisit our previous code. This is the code that we've created in our previous video. If you'll notice, I have a class, I have two instance variables, and one instance method. As of this time, I haven't really written any constructors just yet. Now, if I am going to write a specific constructor for this class, I would probably put it here. Okay, so let's say public person, and then open close parentheses, and then the body. This is what we call a constructor. It's like a method, okay? And whatever's the name of your class, it must have the same name. So if my class name is person, then my constructor should also be called person. It's like a method because it has, or it can have, argument list, and it can also have its own set of body. But the only difference is it should not have any return type. If you see this instance method here, public void say hi, the name of the method is say hi, and this is what we call the return type. Since my method say hi will not return anything, the return type will be called or will be named as void. But for constructors, even if it doesn't return anything, we should not put void here. Because if we do, this is not a constructor anymore. This right here becomes a method. So let me remove void there, and then we can now put some codes right here. Now, let's go back to our notes. Constructors are used to construct or to instantiate or to create objects. So depending on what book you're reading, these three terms right here are actually the same. They are used to create objects, and they are typically used together with the keyword new. So whenever we instantiate or we create or we construct an object, we use the keyword new together with the constructor. So let's take a look at our test class in our previous video. You notice that in both lines 9 and line 12, we have instantiated two objects, P1 and P2. And then on the right-hand side of the equal symbol, we called a constructor. So we call it using the keyword new followed by the name of a constructor. Remember, constructors ends with a parenthesis. So this one right here is actually a constructor. So whenever you call a constructor, expect that there is a new object that has been created. Now, why do we need to create an object? So let's say whenever we call a constructor, you wanted to put a default value or a set of values to your instance variables. For example, if I will create a person object, I would probably say name equals, let's say, no name. And then age equals, let's say, 0 for now. All right, so let's try to remove the identity of both Joe and both Lawrence and Joe. So let's review this. So right now, I have constructed my first constructor. And then in my test class, I've created two objects, P1 and then P2. And then immediately, what I did was to call their method say hi. Let's try to see what will be the effect in our runtime. right? Notice both of them has the name no name, and both of them were set to 0 years old. Why? Because after creating the first object, we assigned it to P1, and then we called P1's say hi, which actually printed the name and age of P1. Now, the default value that was set for name and age as of this point is only no name and age 0. Same thing happened with P2. We haven't really assigned any values yet. So, normally, after calling the constructor, the next step is for you to assign their unique names and unique ages. So save, compile, and this time we now have a unique value for name and age for both P1 and P2. Okay, now what if we go back here and then in the previous code, we haven't really had any constructor. So why is it that we were able to construct an object? So let me remove this again, but this time I'll just comment this out. So let me go back to our person class. In the previous video, this is actually what we have. A name and age, and then say hi. And then in our test class, we remember in our test class, we can still create two objects. So compile. And this is what we actually had last video. So there's nothing wrong with having, it seems that there's nothing wrong. Oh, I forgot to save this one. Let me save this again. And then let me recompile that again, just to be sure. Okay, and then let me run that again. Okay. If you notice that in the previous video, we haven't really written any constructor, but we can still construct our person objects. So why is that? Okay. It is because that there's a rule for a constructor that in each class, there must exist at least one constructor. If the writer of the code, if the writer of the class does not provide any constructor, a default, no argument, empty-bodied constructor will automatically be provided. Let's say you wrote a code like public class, my class. So since this is a class, now let's say this class was saved under myclass.java. After compiling myclass.java, it should produce myclass.class, right? Now, myclass.class is already a compiled version created by the compiler. Now, inside that Java bytecode, inside that class, will automatically exist this one. Okay? This is what we call the default constructor. And if you notice, the default constructor doesn't really have anything inside the argument. And it doesn't have any codes inside it. Okay? So the default constructor is automatically provided by Java if it sees that the class that you're trying to compile does not contain any constructor. Now, you may ask, why is that? Remember, in our previous video, we mentioned that classes are your blueprints. So this class right here is a blueprint in creating a person object. So your intention every time you draw a blueprint for a house is for you to create an actual house. If you want to build, let's say, a table, you draw a blueprint of a table so that you'll have a guide in the size, the dimensions of your table. Same thing is true for classes. The reason why we create a class is because you are writing, you are drawing, so to say, your blueprint. You intend to create an object out from that class. So that's why Java has that rule for constructors that if, let's say, for some reason, the writer of the code forgot to write any constructor, Java will automatically provide the constructor so that you can still create an object from that class. Now, let me go back here. Since we already have a constructor written for our class person, Java will not provide the default constructor anymore. Okay? So why is it that when I save this and then I recompile test person, and then if I run test person again, why is it it's okay to compile and run it normally? Because the constructor that we have provided matches the way your test class calls the constructor. The way you call your constructor doesn't pass or doesn't have anything inside the pair of parentheses. And that's precisely the constructor that what is the provided constructor looks like. So if you provide, let's say, let me put something here. No? Let's say string n int a, and then let's say I'll put n and then I'll put a. Okay, what does this mean? These are what we call argument lists. An argument list can be provided for methods and for constructors. This means that every time we call a constructor, you must pass one string value and one int value. So an argument list can be a list of variables that can hold the values that you're trying to pass to them, but arranged in a specific manner. So the specific manner that you need to pass values for our constructor, the first one should be a string, and the second one should be an int. So you should accept a string and an int. So whatever value that you try to pass for in this constructor, you're passing it to name. Whatever value that you try to pass here, you're passing it to age. Now, if I save this, and then let's go back here. Remember, in our constructor, in our person.java, should accept a string and an int, while in our test class, we're not passing anything. So take a look at the compilation error that I'm about to get. See, the error happened in testperson.java line 9. So let's take a look at line 9. This is line 9, and it says here, required string int. Required string int. Meaning, when we go back to our person.java and we call a constructor, it is required that whenever you call this constructor, you're supposed to pass a string and an int. What the Java compiler was, it found no arguments. All right? So, the reason? Actual and formal argument lists differ in length. It simply means that the compiler was not able to find anything, any argument that you're trying to pass for the constructor call. So let's try to do this. If I, let's say, try to pass a value right here, let's say Lawrence, and then Lawrence is age 25, okay, and then let's try to pass the identity of Joe, and then let's say Joe is 10 years old. All right, let me remove this part right here. Okay, so what we did here was we created two person objects. The first person object called a constructor, passing values to it. And then the second object was created, same thing, passing a value, a string and an int value to the constructor. And then this constructor will be called, the only constructor that we have, in fact, will be called because the default constructor will not be present anymore because of the rule. Remember, if the writer of the code does not provide a constructor, Java will provide a default constructor. But since we already have a constructor right here, Java will not give you the default constructor anymore. So let's try to save this, and this time compile it, and then run it again. So see, the first object is still named as Lawrence, and it has a value of 25. And then Joe will still be 10 years old. Now, is it possible for us to create multiple constructors? The answer is yes. So classes can have multiple constructors simply because it can be flexible enough to have different ways on how to create an object. Let's try to overload the constructor. So let's say public person. Let's say, let me provide an empty argument right here. Okay, so let's say every time I create a person object and I did not pass any value to it, I should set the name to it's a assigned default value. Let's say no name, and then age, set it to 0. Okay, so let me save that. Now let's try to create a third person object. Let's say person p3 equals new person. Right. Now, notice how P1 and P2 were created. We pass a string and an int for both constructor call for P1 and P2. But for P3, we're not passing anything. Now, is this acceptable? Let's take a look. Save. All right. Oh, before we compile, let's call the sayHi method, since we say that every time we instantiate an object, a copy of all of these variables and methods will be given to each object that we've created. Since we have the third object right here, this third object will now have its own copy of say hi. So let's try to save that and then recompile it again and then run it again. There. Notice we have created 3 objects. P1 will now have the identity of Lawrence at age 25. P2 is now called Joe at age 10, while P3, when we called the constructor of P3, we did not pass any value to it, any arguments. Therefore, when we call P3, this is what we got. Okay, we did not got any name and we did not assign a value from any value to it because we're trying to call this one. All right. I hope this has been a fun lesson to you. So in our next video, we will try to create other types of methods, both methods that can accept values and assign values. Okay. So that is it. That's it for now. Happy coding. Hello again. This is Lawrence De Camora of Learning While Practicing. For this video, we will talk about methods. Now, the general syntax of a method is like this. We need to provide a set of modifiers first, followed by a return type, followed by the name of the method. And then, after the method name, you should have a pair of parentheses that can include the list of argument lists. The list of arguments that you put right here are a series of variable declarations depending on the type of values that you're trying to pass to a certain method. Let's say you're trying to pass a string and an int. In our previous example, we have a constructor that has a set of arguments that can pass a string and an int. That can also be done for methods. A method may or may not have an argument list. And then a method may or may not have any return value. If a method does not have a return value, the return type that we need to provide should be void. If a method should return a value, the return type should match the type of value that you're trying to return. In this case, an int. Meaning, every time I call celebrate birthday, I need to return an integer value. So let's have a look at some examples right here. Let's take a look at the first one. The method sayHi does not accept any value whenever you call sayHi. It doesn't have any argument list. It will simply do a set of codes like printing hi, and then after that, it should not return any value in return. It should not give you anything back. That's why the return type set here is void. While the second one, public int celebrate birthday, we still have no declared argument in the method celebrate birthday. The return type, however, is an int. So every time I call celebrate birthday, it will do some codes like incrementing the age by 1. And then it's very important that we have the return keyword. The return keyword will now return a specific value back to the calling method. So let's say in your main method, you try to call celebrate birthday, the value of age will be returned back to the main method. That's why the return type right here is an int because age is assumed to be an int. Now, the third one, public void set name. Whenever we call set name, we are supposed to accept a value whenever set name is called. That string value can now be used to assign any other variable. For example, I'm going to accept a value, a string value right here. That string value can be used to update the value of name. But after doing that, there's nothing else to return. That's why the return type is void. And the last one right here is public string get name. So whenever I call get name, I should not pass anything. I'll just call get name and then open close parenthesis. That's it. And every time I call get name, I'm supposed to accept a value, a string value to be more specific, a string value in return. That's why we have the return statement right here. Notice that for each method that has a return type, the return keyword can be seen. Putting a return statement inside a method will simply return a value back to the calling method, or you're simply allowing a jump back, or you're allowed to return back to the calling method. So even void, a method that has a return type of void, can also call return. This is also allowed, but in this example, you're simply saying, I would like to return back to the calling method. Not necessarily mean you're returning something back because the return type here is void. Let's try to apply method calls in our class person. So let's say, let me provide another method right here. Let's say public int celebrate birthday. So whenever a person celebrates his birthday, whatever age value he has will be incremented by 1. And then we will return back the value. All right? Or we could actually just increment the value and then not return anything back. So let's just put the return type to void. So whenever we call celebrate birthday, we will simply increment the value of age. So let me save that. Let's increment, or let's create P1, P2, P3, call their high method, right? And then since P3 doesn't have any identity just yet, let's allow P1 to celebrate his birthday. So we say P1 dot celebrate birthday. And then let's call the say hi of P1 and P2 again. All right, so we printed the value of P1 by calling say hi, and then P1 celebrated his birthday, and then let's print the identity of P1, P2, and P3. Let's try to compile the test class again. Java C test person, and then let's run test person again. So here you go. My name is Lawrence. I'm 25 years old, and then calling celebrate birthday here. My name is Lawrence. I'm 26 years old. So there you go. We're able to update the value of the birthday by calling celebrate birthday. Now, our celebrate birthday doesn't return anything, and you're not supposed to accept any value to it. Okay, let's try to provide another method right here. Let's say I am going to write another method, public void set name. This time, I'm going to accept a string value. Okay, and then I'll say name will get the value of n. So if I call set name, I'm supposed to pass a string value to it. And then n right here will be a temporary variable, or also known as a local variable. It will be used to accept the value, and then whatever value that was passed to n will now be passed to name. This name right here is your instance variable name. Right? We're trying to update the name. So if I wanted to change the name of P1, I would say P1 dot set name, and then I'll pass a string value to it. Let's say Lawrence de Camora. Okay, so let's try to save that one. Let's print. Let's compile it. Oops, P1 dot set name Lawrence de Camora. Oh, what happened? We haven't saved this class. So let's save this as well. And then let's recompile. All right, there we go. And then Java test person. So my name is Lawrence. This was the first time say hi was called. And then my name is Lawrence de Camora. Notice that after celebrating birthday and then setting the name from Lawrence, it was reset. It was changed to Lawrence de Camora. And then we call P2 and P3. So P2 is Joe, P3 is no name. Okay, so far we have three methods. Okay, the first method is say hi. The second instance method is celebrate birthday. And the third one is what we call a setter, a method that can set values to your variables. Okay, what if I would like to retrieve the name of a certain object? Let's say public string get name. So in this example, I have a method. This is called, also known as a getter. So in this sample method, I have a setter, a set name method, and a getter, a get name method. The setter, whenever we call it, we're supposed to pass a string value to it, and it shouldn't return anything. That's why you don't have a return keyword inside the setter. But in our getter, whenever I call it, I'm expecting to return a value. That value should be of string type. So therefore, I need to have the return keyword here. I should say return, and then I should return a string value. Now that string value is represented by name. That's the value that I'm trying to get. So let me save this one. Let's write a test class, a method called right here. So let's try to remove this so that we can have a clear output. And then I'll say system.out.println. I would say just hi, and then concatenate the name. I'll say p1.getName. Now, you notice that the getter call is now inside the main, the println method. Okay, this is all right because the return value that we're going to get from our getter call from p1.getName will simply be concatenated to hi. So we will first say hi, display the name and age of Lawrence, and then we will increment the age of Lawrence by celebrating his birthday, and then we will set the name. We will change the name from Lawrence to Lawrence de Camora, and then we will now display just the name. So save it, and then recompile it, and then rerun it again. So there you go. Hi, my name is Lawrence. I'm 25 years old, and then my new name is now Lawrence de Camora. That's the one that I'm trying to print here after calling a bunch of methods. All right, so I hope you've learned about methods in this video. In the next video, we will now explore an introduction to object-oriented programming called encapsulation. Happy coding! Hello again, my name is Lawrence of LearningWhilePracticing. For this video, we will talk about encapsulation, or sometimes called as data hiding. let's review our previous code. In the previous video, we've created the class person. We've introduced the concept of instance variables, constructors, and instance methods. And then also, in our test class, we tried to call those variables, and we've used the constructors in creating objects. And then we've also called some of the methods that we have created. Okay. So let's first define what encapsulation is. In declaring your instance variables as public, like what we did here, we allow global access to it. So we have two instance variables, public string name, public int age, and because they're declared public, their accessibility is not limited. They have a global access. Let's try to erase this first. Okay. Looking at P1 and P2, we have instantiated both objects having default values to them. Okay, let's try to, in this test class, we have created P3. And if you notice, P3 doesn't have any values to its name and age because what we did was we used a constructor that sets its value to a default value, which is no name and age to 0. So let's try to assign a name for P3. If we say P3 dot name, let's say it's equal to Walter, and then let's say P3 dot age, let's say let's set him to 15 years old. All right. Now, if we print the values of P1, P2, and P3, okay, we will probably use a system.out.println methods. We can say P1.name, okay, and then let's say at age P1.age. And then that's for P1. Let's do a quick copy paste right here. Okay, for P1, P2, and P3. For the age, we also have P1, P2, and P3. Let's try to save this. And let's see what we got right here. Java C test person dot Java test person. There we go. So we have three objects, P1, P2, and P3. P3 was initially created using a constructor that doesn't accept or that does not have any values passed to it. So we ended up setting the identity of P3 in lines 16 and 17. Okay? And then in the last few lines, we've printed their values or their identities. Okay. Now, this sample code here seems to be working just fine. But what if we change the value of P3 to, let's say, -5? Do you think this one will work? Think of it for a second. If you say yes, then you're correct. Since P3 is an object that calls the age variable, and age variable is an int, assigning a whole number value, whether it's a negative or a positive number, is allowable. Even if it doesn't make any sense, because in the real world, I don't know anybody who has an age that has a negative value to it. So assigning a negative value to your variable age can be allowed simply because age is an int. Also, age has a public access. Public means global access. You have a wide range of access within the class, outside the class, within the package, or anywhere in your code. That's why in our test class, we were able to access age directly. And that can be bad, like what you're seeing right now. So to limit its accessibility, we can declare your variables as private. So private means we are limiting the accessibility only within the same class where you have declared it. So if I change this to private, as well as this one to private, if we save this, and when we recompile our code, take a look at the compilation errors that we will get. There's a lot. Okay? There are 8 errors. Now, notice the location of each errors. You'll see that for each error, you're trying to access the private variables directly. So you have p3.name, p3.age, p1.name, p1.age, so on and so forth. Now, since we have declared them private, we're not allowed to access them. So let's take a look at this one. In testperson.java, in line 16, where's line 16? This one. Okay, the error is name has private access in person. Therefore, we're not allowed to do this. Okay, by doing so, meaning by declaring your variables as private, you are hiding your data from direct access. Now, if this is the case, so how can we assign values to the name of P1, P2, and P3 if we're not allowed to do this? To allow access to your variables, a pair of setter and getter methods can be provided. So what are setters and getter methods? These are methods that follows a specific pattern, and we use these public methods to allow us to gain access to your private variables. Okay, setters are sometimes called as mutators in some books, and getters are sometimes called accessors. They are used to mutate and access your private variables. So let's take a look at the pattern that I'm talking about. So if you have a private variable, private string name, your setters should be public, and then all setters will return a void type, void, and then we follow a specific naming pattern. So if your variable name is name, you say set and then name. And then a variable that can be passed to your arguments should be of type string, because that's the data type of name. And then we can now access, or we can now accept the value that you pass to it. We can now say name will get the value of n. Okay? Now let's take a look at another variable declaration. Let's say private double weight. Now, having setters, you can also provide certain validation checks. For example, in the real world, we don't know anybody whose weight is less than 0. Everybody should have at least a certain amount of weight. So 0 and below is not allowed. So we can say public, okay, because it's a setter, it should start with public. The accessibility should be public, and then the return type should be void. And then the name of your variable is weight, so we say set weight. Okay, now consider the data type of weight, that's double. So you need to be able to accept a double value. Say double W. Now, whatever value that you try to pass to this method set weight can now be tested. Okay? So in this first example, whatever value that you try to pass to n, you're simply assigning it to name. Now, you can also use setters to provide validation checks. So we can put a check here, an if condition. So testing if weight, the value that you're trying to pass, is greater than 0. If it is, then you say weight will get the value of whatever value that you try to pass. Else, okay, so you can assign a default value for weight. We can say weight is equal to, let's say a default value would be 1.0. And then if you want, you can even throw an exception. Okay, we can say throw new illegal argument exception. Now, what is this for? For now, we will just comment this out. Exceptions will be discussed in a different module, but it's a way for us to have a representation of small or minor errors. For now, let's just comment this out. Okay? So you'll see that there are two versions of setters right here. We have a setter that directly accepts values, or another setter that can test the value first before accepting it. Now, so much for setters. Let's talk about your getters. Getters are intended for us to get or retrieve values of our private variables. So if you have private string name, your getter should be public. And then the return type, this time, should also match the return type of your variable. So if you have string name, your getter should be public string get name. Now, the values of your getters are pretty much standard. So we simply say return and then the name of your private variable. We say return name. That's it. For your weight, for variable weight, you follow the same set of pattern. We say public double get weight. And then same body. We say return weight. All right? Now, let's try to apply this concept to our class person. In our class person, we have two private variables. We have two constructors. We have a bunch of created methods in the previous code. Now, we already have our setters and getters right here. So let's just retain our set name. So this is our setters. Okay. What else do we need? We also need a setter for the age. So we say, since your age variable is private, we can say public void set age, and then we say int a. Now, this type of setter will also we will also need to have a validation check, because as we all know, negative age value is not allowed for any type of person. So we can say we can put an if condition here, and then we can test what value that we're trying to pass right here. So we say if a is greater than or equal to 0. Now, this time we're using greater than or equal to. Why? Because a valid age value for a person starts from 0 and above. Let's say a baby is a newborn baby, that's 0 age, right? So 0 is actually an acceptable value for your person object. So we say if a, or the value that you pass to set age, is greater than or equal to 0, we accept it. Age is equal to a. Else, we set it to 0, because negative values are not allowed. All right? Now, for your getters, we will retain our get name, and then this time we also need a public int get age method. And then we say return age. All right, that's it. Let's save that one. And this time, we don't have a problem for P1 and P2. Here in our test class, what we have is this. No? We have a problem for P3. So since we're getting an error right here, we need to change this to p3.setName. We will now be forced to call our setters. So p3.setName, we're setting the name of Walter for p3, and then we say p3.setAge. We're setting the age to, let's say, what was the age earlier? We're assigning -5, but Walter is actually 15 years old. All right. Now, as for our printing, we will not be allowed to use these anymore. Let me just do a quick copy paste so that I won't have to type everything. Okay, so if we wanted to display the name of our objects, we should say p1 dot get name, and then at age p1 dot get age. All right, so instead of calling name and age directly, we will now be forced to use our getters. So let's make calls for p1, p2, and p3. p1, p2, and p2 and p3. Okay, save this, and then let's see if we still have those errors. Compile, no more errors. Let's try to run them. And there you go. We have successfully printed the values of all your 3 objects. So, just a quick recap. Declaring your variables as public may not be a very good idea because you allow global access to your variables, which means we cannot filter the values that you're trying to pass. As long as those values are strings in nature or an int in nature, you can assign them to name and age if we declare them public. But since we have declared them private, the accessibility is now limited only within the same class where you have access or where you have declared your instance variables. So the challenge is, how do we allow access to your private instance variables? We will now create your setters that will allow accessibility to set values to your private variables, and we will also create getters to allow allow access to your private variables. So if in other classes you attempt to assign values to them or print values of your private variables, you will be forced to use those setters and getters. Also, for setters, you can perform certain validation checks inside your setters. There are some setters that will simply accept the value, or you can test the values first for further testing, for further validity. These tests can be patterned in real-life objects. So this is what we meant when we call encapsulation, or in some books, they call this data hiding. In our next video, we will discuss the concept of Java documentation. That's it for now. Happy coding! Hello, my name is Lawrence of Learning While Practicing. For this video, we will discuss the concept of your Java API documentation. What's the purpose of your API documentation, and what does API means? API stands for Application Programming Interface. It is an essential part of your JRE once you have installed your JDK and your JRE on your local machine. In your first video, in our first section, we've talked about the installation of your JDK. And once you have installed your JDK, what you're installing is actually a set of tools for your development, like your compiler, your JRE or your Java runtime environment, your database, and other utilities. Now, your Java development kit, once you've installed this, you'll notice that it has another application that is being installed with it, and that's your JRE, that is composed of 2 things: your Java virtual machine and your API. or your application programming interface. Your API actually contains a set of pre-created packages, a set of pre-created classes and methods, and that can be used by us, by the developers. So we've been using this set of pre-created classes in our past programs, like in public static void main, we use the class string for string args. And in printing your output, we use the method system.out.println. System is also what we call a type of pre-created class. These pre-created classes were created in the past so that our lives as developer can be easier. You simply need to call these classes. Now, how do we know what are the set of pre-created classes that we have? We need to have what we call the API documentation. And this API documentation can be accessed in two ways. You can access them online or offline. Online, if you have an internet connection where you can connect to the internet and then typing a specific URL address. And you also have the offline version. And in order for you to do this is you need to download a zip file from the Oracle website. Now, let's try to do the offline first. So just open a browser, your favorite browser, and then key in Java Doc API, and then the version that you would like to use. In our case, I'll be using version 8, and then download. Press enter. Now, you need to look for the first Oracle link that you will encounter. And then this one talks about Java Development Kit 8, Documentation, Oracle. So let's try to look for this one. And this is the correct landing page, Java SE Development Kit 8, download. And the product is your documentation. The file size is about 118.72 MB, and it's a zip file. So let's download this one. We might be asked to review and accept a license agreement from Oracle. Click download. Now, depending on your internet speed, it will probably take a few minutes to a few seconds. Okay. Now, at the time that this video was shot, we're using version 8. All right. Now, after the download, so it will take a few more seconds. After the download is finished, we can now extract that zip file and then open the contents in your favorite browser. Okay, let's take a look at 2 seconds, 1. Okay, so the download is already finished. And this is what we have so far. Let's try to move this to my folder called Mac Installers. Let me drag it here. Okay, this is where I'll extract our zip file. So let me extract that. It will take probably a few seconds to extract. Okay, now after extracting, we will take a look. You will expect a docs folder, and inside that docs folder, you will see a bunch of more folders. Look for the API folder, and inside the API folder, you should see index.html. That is now your landing page. You can now open this using your favorite browser, and this is your offline version of your API. Now, it will be better if you will bookmark this. So bookmark. Sorry. Let's bookmark this tab. Okay, so let's bookmark that one. So that if you try to access your API again, you simply need to click your bookmark. Okay, so that's one way. You'll see that it's using the file protocol to access index.html. Now, how about the online version? Let's open a new tab. So if you're accessing it online, you follow this specific pattern. just key in docs.oracle.com, Java SE, and then your desired version, and then docs/API. So type in docs.oracle.com/Java SE slash and then the version. For example, we wanted to see the JDK documentation for version 6, and then slash docs API, docs/API. So this is the API documentation of Java SE6. If you want to access the API documentation of Java SE7, follow the same pattern. Let me just copy this one, paste it here, and then just change the version. Let's say I would like to see version 7. So this is the Java API documentation of version 7. Now, let's try to access version 8. Just key in 8. So docs oracle.com, Java SE, version docs API, and here we go. So this is the online version of your API. Compare it with what we have bookmarked. So they look the same, right? But they're being accessed differently. This one is online, while this one is offline. The nice thing about having it offline is wherever you go, you don't need to worry about your internet connection because you already have a copy of the API documentation for Java 8. Now, let's discuss the different parts. The upper left part contains all packages for Java 8, while the lower left part contains all classes. At first glance or at first loading, you will see all classes right here arranged alphabetically. And it contains a lot of classes. So if you wanted to look for the class string, all you need to do is to scroll down a bit further, look for the string class. There we go. Click it. And then this is the write-up for the class string. This is class string. It can be found in this package. Now, what are these packages for? These packages actually groups all of these classes into logical groupings. For example, if you wanted to look at the list of classes for GUI, you might want to look for the Java AWT or the Java.awt package. So if you click this, the only classes and interfaces that you will see are the AWT classes. If you want to look for classes that is involved in input-output, you can take a look at the java.io package. So these are the classes for I/O. Now, there's always a default package called java.lang. Java.lang contains classes and interfaces that you don't need to worry about, that you don't need to import, because by default, all of these classes are accessible, like the system class and even the string class. So right now, we're looking at the string class. If you scroll down further, you will see the write-ups. If you have the time later, you may want to go through them. Okay, and then if you scroll down a bit further, you will see the field summary, the constructor summary, and the list of methods that the string class contains. For the system class, you can also scroll down and then you will see the same set of pattern. All right? So, knowing the type of class is not enough. It's better to have access to your API documentation so you'll have an idea what constructors, what variables that you can use for a specific class. For example, in the integer class, how am I supposed to create an object from an integer class? In our previous videos in section 2, we've talked about constructors. So all you need to do is to scroll down and look for the constructor summary. And you'll see that there are 2 different constructors for the integer class. The first one, you should pass an int, while the second one, you can pass a string. But for the string class, in order for you to create a string object, let's take a look at the constructor summary. You can use any of, this is your constructor summary, you can use any of these constructors. And you'll see that there's a lot of constructors for the string class. It only means that there's a lot of different ways we can use in creating a string object. Okay. So let's take a look again. So this is our index.html. In the next section, we will take a look at, in the next video, we will take a look at what are Java packages. And what if I need to use a class from a different package? So we will talk about the import statement. Happy coding! Hello, this is Lawrence of LearningWhilePracticing. In our final video for this section, we will talk about the import statement. Let's say you wanted to ask the user for a certain set of inputs. Unlike in our current code, in our test class, we have hard-coded the values of P1, P2, and P3. For P1, the name is Lawrence and his age is 25, while P2, you have Joe at age 10, and Walter, P3, you have age 15. Let's try to be more interactive this time by allowing us to accept inputs from the user. Like what we did in the previous video, we have bookmarked our API documentation. So in accepting an input, we might need to use what we call the scanner class. So in order for us to use the scanner class, we need to declare, or we need to use the statement scanner. Okay, we're declaring a scanner object. Let's say scanner s is equals to new scanner. And then since we're accepting an input from the keyboard, we use system.in. Now, in displaying an output, we use system.out. In accepting an input, we use system.in. But that object that we will use to accept an input needs to be wrapped around a scanner object. So our scanner object is S. So when we create a scanner object, it is ideal that we close it before we end the code. All right, so we're opening a scanner object, we're closing the scanner object. But the scanner object can only be found under java.util package. Like what I've mentioned in our previous video, this is your API documentation. Now, the upper left part of our API are your list of packages, while on the lower left of your API are the list of classes. Now, in the middle part are your write-ups. So for example, you probably need to know more about a certain class. Let's say, I'd like to know more about, let's say, buttons. So you just need to scroll down and look for the class button. If you find it, you'll see that you can read all about buttons right here. You will see the hierarchy, you will see the class structure, and the write-ups, and of course, the list of field summary or attributes and constants, the list of constructors, and the list of methods, only for that specific class. So if you're not familiar with the location where your class is, you can see it right here. This is your package location where you can find the button class. By default, the API documentation, it arranges its classes in alphabetical order. So if you're already familiar where to look for a specific class, you could simply look for the package and then click on that package, and it will only display the list of classes and interfaces specific for that package that you've chosen. So here's your button class again. But we're not here to talk about buttons. We're here to talk about the scanner class. So the scanner class can be found under java.util. So we need to scroll down a bit, click on java.util, and then Under the lower left part, look for the scanner class. Right? So the scanner class is right here. And if you scroll down a bit, you will see the list of constructors that we can use. And what we're using, okay, so this is your list of constructor. What we're using is this. Okay, so a scanner constructor that accepts an input stream. System.in is a type of input stream. Okay, now after declaring your scanner object and after setting all the properties, we can now change of the information that we've set for any of this person object by accepting a set of inputs from the keyboard. Let me just remove this right here. Okay, so let's say we decided to change the info of, let's say, P3. Okay, from the user input. Okay, so what we need to do is to inform the user first by using a message, an output message. Let's say enter the name for P3. And then somewhere on the next line, we can also do the same for the age. Okay, enter the age for P3. All right. Now, if we asked for the user a specific input, let's say name, okay, we need to store it to a certain variable. Let's say string name. Okay, so we're going to store it to this variable right here. Since we're asking the user for a string input, we need to use the scanner object to accept that input and then a next method. So let's say next right there. Okay, so this one will accept a string value. Now, if you're using an int for the age, we need to declare a variable first, say int age, and then we can also use the same object s and then say next int. Now, next int will allow you to accept an integer input. Next will allow you to accept a string input. We will discuss more of the next methods under the scanner class in the next section. Okay, for now, let's just do this for now. And then after accepting these inputs from the user, we can now store these inputs to the P3 object. We can now say P3.setName and then accept the value of the name, and then P3.setAge, and then let's pass age right here, right there. Right? Now, the only thing is we will, when we save this, let me save this now, and when we compile this, we will definitely get a compilation error. Let me just open my terminal window. Okay, so let me go inside Java codes, section 2. All right, so take a look at the error that I'm going to get. If I compile testperson.java, boom, I have an error right here in line 8 and as well as right here, same line number, line 8. Both of these errors are pointing to the same scanner class declaration, scanner class declaration, scanner class instantiation. So right here. Now, the reason behind this is in Java, we have what we call a default package. It's a package where you don't need to import. Okay, so let's take a look at the default package. This is your java.lang. And the reason why it's called the default package, because any class that you use from this default package, you don't need to declare them. You don't need to import them, like the string class. We've been using string since the first section, or since in section 1, as well as the system class for printing output. And if you notice, we don't even have an import statement in our code because the system class and the string class, they both belong to the same package. But for the string class, for the scanner class, it belongs to java.util. Scanner, let's go to scanner, there we go. It belongs to java.util. So if you want to make use or gain accessibility in the scanner class, we might need to put this on top of our class. Let's say import java.util.scanner. So this is the name of the package followed by the class name. So if you save this, and when we compile this again, there we go. Okay, so we can now test our code. Test person. Enter the name of P3. Let's say Peter. And then the age, let's say it's 16. So there we go. We're now getting the value from the keyboard input for P3. All right. So we will encounter more of this import statement in our next set of code. But before that, let's talk about the structure. There are two ways on how to declare an import statement. So first, if you need to gain access to several, let's say, let me just go back here. If you want to gain access to, let's say, several classes, let's say you have arrays, you have, let's just put some other classes right here. Let's say array list hash set. Now, if you look at the scanner package or the java.util package, you will see that we have arrays and array list. We also have hash set right here. They all belong under java.util. So a convenient way to import all of these four classes right here is by using import, the name of the package, and an asterisk. Okay? So the asterisk right here represents all classes under the same package, java.util package. Okay? And also, it's worth mentioning it again. If you need classes under the java.lang packages, there's no need to import the java.lang package. Because by default, Java already has a direct access to classes under java.lang. Okay? So in our next section, section 3, we will start the discussion on IDE. So if you notice, for the past few videos, we've been using a text editor. I think it's about time that we use an IDE or an integrated development environment in coding our codes. And we will revisit the import statement and the scanner object on the latter part of that video. All right? So this has been Lawrence of Learning While Practicing. Happy coding!